This is the second video for the exam 4 review. So we're going to be reviewing statistics now. And number 1, it says use the following words to fill in the blanks. And we've got several words here that deal with statistics. And so we're going to fill in the blanks. It says a poll of 1,500 registered voters in Texas was taken to determine who they favored in the last presidential election. In statistics, these 1,500 voters are referred to as the sample, and all registered voters in Texas are referred to as the population. Normally, certainly in a situation like this, there's no way to poll the whole population, and so you poll a sample. In Part B, it says this sample is considered representative if it's a small replica of the entire population with regard to income, education, gender, race, religion, etc. Letter C, the sample is random if it is obtained in such a way that every item or person in the population has an equal chance of being selected for the sample. So in other words, if you had a database of all Texas registered voters and you could randomly choose 1,500 people, there's all sorts of programs that do that, that would give you a random sample. In letter D, descriptive statistics is the branch of statistics concerned with collecting, organizing, summarizing, and presenting data. Inferential statistics is the branch of statistics that involves making generalizations about and drawing conclusions from collected data. And really, that's the whole point of statistics. After you've collected and put all the data together, you're hoping the data tells you something, that you can learn something from the data. In letter E, the range and the standard deviation, standard deviation, are measures of dispersion. Remember, measures of dispersion tell us how spread out the data is. All right, let's move on to the next slide. It says here, use the frequency distribution for students' scores on a math test to find the following. So this is a grouped frequency distribution table, and we have classes here, and the frequency in each class. So for 40 to 49, there were 7 pieces of data, for example. So in A, it says the total number of observations. Well, to find the total number of observations, we'd have to add the frequencies, and so that would be 25. So basically, 25 scores were recorded in this data. Letter B, the width of each class. So each of these is a class, and the width, well, let's see, if you go from 60 to 69, be careful, it's not 9, it's actually 10. You can count it out, 60, 61, 62, 63, all the way up to 69. You'll see that there's 10 in each class. So that's what we call the width. In C, the lower class limit for the first class, so this is the first class, and the lower class limit is the lowest number there, which is 40. And then the upper class limit for the second class, so here's our second class, and the upper class limit would be the largest number in that class, which is 59. In problem 3, it says students had the following scores on an English quiz. Find the mean, median, mode, mid-range, and range for the test scores. All right, so for the mean, you'd have to, you know what, I don't need it yet, but I'm going to go ahead and put these in order. And for the mean, we would just add them all up and divide by how many there are. I believe there's 17. And you should get 6.4. For the median, you just look for the middle value now that they've been ordered. So just remember, when you find a median, you always want to order the data first if it's not already ordered. In this case, the 7 is the middle piece of data. In other words, you'll find the same number of pieces of data on each side. And so 7 is our median here. And for the mode, the value that occurs the most is 8. For the mid-range, we're going to subtract the, actually we're going to average the smallest and highest value. And I think I actually skipped that. The range, we subtract the largest from the smallest value, which makes that 8. So for the mid-range, which I missed, you just average the lowest and the highest score. So 10 plus 2 divided by 2, and you get 6. So the mid-range is just a quick way to find a measure of central tendency. It may or may not be, accurate enough depending on what you're doing. All right, let's move on to the next slide. So in number 4, it says the following list gives the sales price for 6 homes that recently sold in a neighborhood. Find the mean and median price of the homes and determine which measure is a better measure of central tendency in this case. All right, so again, I think I'm going to go ahead and order the data. Of course, to find the mean, you would add them up and divide by 6, since there's 6 pieces of data here. And you should get $185,333.33. So these are home prices, or the price of homes. Let's see, the median, in this case, notice there's 2 values in the middle, and we're going to want to average those, and when you do that, you get 200,000. Now it says, which is a better measure of central tendency? Well, if you look at the scores, this 90,000 is really an extreme value that really pulls down the average. If you look at the mean, it's 185,000, and there's only one home that's less than that, and then all the others are at least 10,000 more than 185,000. That $90,000 is really bringing the mean down. In fact, we say that the mean is sensitive because we weigh each piece of data equally, and if you have an extreme value or two, it can really make a difference. In fact, in a case like this, sometimes people would drop the 90,000 and take the average of the other 5 numbers. If you did that, you would get $204,400, which is closer to what would be average in this set of data. Of course, the median is not really affected by outliers, in this case the 90,000. So which is a better measure? The median is better because it is not affected by the outlier 90,000. All right, let's move on to number 5. It says find the mean and the median for the quiz scores in the frequency distribution to 2 decimal places. All right, so the first thing you're going to want to do here, well, actually, let's write down the formulas. X bar, or the mean, is the sum of the XFs, where we're going to multiply each score times its frequency, and then we're going to divide this sum by n, which is the number of pieces of data. So let's go ahead and first find all the XFs. So in the first row, we have 1 times 2, which is 2. And we can do that for each row. We're just going to multiply the 2 numbers. And you can do that, and you should get the numbers that I have here. And then we're going to want to add all those up, and you get 467. If you add up the numbers in the frequency column, you'll find out how many pieces of data there are, or what your n value is. So here n equals 71. So this becomes 467 over 71, which is about 6.58. It did say to 2 decimal places. All right, so now we also need to find the median. So, So first of all, we know the median using the positional value formula is n plus 1 over 2, where n is the number of pieces of data. So it'll be 71 plus 1 over 2, or 72 over 2, which is 36. So the median will be in the 36th position. And so now we need to count positions. So if you look at the first row here, notice there's 2 ones. And so the second one would be in the second position. Now in the next row, we have 2 more pieces of data, 2 2s. And so the second 2 would be in the 4th position. And you can see that if you add these 2 numbers here, you get the 4. And so in the next row, there's 3 pieces of data. So the last 3 would be in the 7th position. Again, that's 3 plus 4. And if we go again, 7 plus 5 gives us 12. 12 plus 6 gives us 18. And 18 plus 12 gives us 30. Just adding those numbers. And 30 plus 15 is 45. And notice we have now passed the 36th position. The last 7 is in the 45th position. And so you can see in the 36th position you would have a 7. And so the median is 7. Now I said mode there, but that should be median. All right, let's move on to the next slide. It says find the range and the standard deviation for the data. So first of all, to find the range, all we have to do is subtract the biggest minus the smallest number, and here you're going to get 11. And then now we need to find the standard deviation. So when we do that, we make 3 columns, and these are our titles. So we have our data, we have our deviations from the mean, which we just subtract the data minus the mean there. And in the last column, we're just squaring what we get in the middle column. So our data goes here, and then data minus mean, so we need the mean. If you find the mean of this data, you should get 12. And so in the first entry here, we're going to have 7 minus 12, which is negative 5. So notice the data value 7 is 5 below the mean. That's what that really means. And you can do the same thing with 9, and you get negative 3. So 9 is 3 below the mean. 11 is 1 below the mean, and we can continue on. Notice 15 is 3 above the mean. 18 is 6 above the mean. Of course, 12 is the mean, and so there's no difference there. Or the difference is 0, I should say. So let's go ahead and square our values. Negative 5 squared is 25. Negative 3 squared is 9. Negative 1 squared, of course, is 1. 3 squared is 9. 6 squared is 36. 0 squared is 0. So the next step is to add up these values. And we're supposed to divide by n minus 1. Now n is just the number of pieces of data. And if you look at the data here, there's 6 pieces of data, so n is 6. And so this becomes 80 over 5. 6 minus 1 is 5. And of course, that's going to equal 16. Now, last thing we need to do is take the square root of this value, and so we get 4. And so the standard deviation is 4. So the last thing we're supposed to do, notice it says explain the meaning of the standard deviation for the data. So I think it's important not only that you know what the standard deviation is, but that you understand what it means. On average, the data is about 4 from the mean. And in fact, you can see that just looking at the data here. That's definitely a reasonable number considering what we're seeing there. All right, let's move on to the next slide. It says, how are the mean, median, and mode related in a normal distribution? Well, they're all the same. On number 8, it says, the scores on a test are normally distributed with a mean of 80 and a standard deviation of 6. Find the score that is 1.5 standard deviations below the mean. Now, normally distributed, if you look at our diagram, this is for number 9, but that means you're going to have a bell-shaped curve, and you're going to have symmetry, and we have this rule, the 68, 95, 99.7 rule. We'll get to that in just a minute. In this problem, we just need to understand the basic idea of a mean and a standard deviation. So if the mean is 80 and a standard deviation is 6, then 80 plus 6, which would be 86, would be the value that's 1 standard deviation above the mean. Here we want the score that is 1.5 standard deviations below the mean. So what we want to do is we'll start with 80, and we're going to subtract off 1.5 standard deviations, or 1.5 times 6. And so you get 71. All right. So on part B, it says find the score that is 3 standard deviations above the mean. So you would start with 80, and then basically you're adding 3 6s, or 3 times 6, and you get 98. All right, and number 9, it says the figure illustrates a normal distribution for prices paid for a particular model of a new car. The mean is $18,000 with a standard deviation of $2,000. So notice this mean, this 18 stands for 18,000, and you just add 2,000 and you're at 1 standard deviation above the mean, which is 20,000. So that's what's going on here. It says use the 68, 95, 99.7 rule to find the percentage of buyers who paid between 14 and 22,000. Excuse me. So that would be in here. And you can see that would be 95%. So basically 95% of the buyers paid between 14 and 22,000. In other words, they're within 2 standard deviations of the mean. And so let me go ahead and write that. Find the percentage of buyers who paid between 12,000 and 18,000. So 12,000 and 18,000, that's this here. Well, we know that this whole distance from here to here, or I should say from 12,000 to 24,000, whoops, I went too far. Yeah, actually, I have that right. From 12,000 to 24,000, we know 99.7% of the data is in there. And what we're looking at is just from 12 to 18, which is half of that. And so we just need to take half of 99.7, and you get 49.85%. All right, let's move on to the next slide. The ages of people living in a retirement community are normally distributed with a mean age of 68 years and a standard deviation of 4 years. Use the 68, 95, 99.7 rule to find the percentage of people in the community whose ages are, and so we've got 3 questions to answer here. So the first thing we're going to want to do is draw a picture. We need a bell-shaped curve since this is a normal distribution. And I'm going to go ahead and put my marks First the one is at the mean, and then the ones on the ends. And I want 3 standard deviations above and below the mean, so I need to put 3 equal marks on each side. And so now we're ready to label. Of course, the mean is 68, and a standard deviation is 4 years. So if we add 4, we're at 1 standard deviation above the mean. Add another 4, we're at 2 standard deviations above the mean. And one more, we're at 80, which is 3 standard deviations above the mean. And we can do the same in the other direction. Subtract 4, you get 64. So the mean, 68 minus 4 is 64. Subtract 4 again, you're at 60. And 3 standard deviations below the mean, you're at 56. So between 56 and 80, well, that's 99.7% of the data. And so that's our answer on part A. So what percentage of the people are between 68 and 76? So that's this here. 76 is 2 standard deviations above the mean. So we know that within 2 standard deviations, we have 95% of the data, and this area that I circled in black is half of that, so we'll do 95% divided by 2, and you should get 47.5%. All right, on this last question, it says, let's see, the percentage of people greater than 80. Well, greater than 80, that would be out here. Now, we already know that inside of these 2 circled areas I have here on the ends, we know 99.7% of the data is within 3 standard deviations, between 56 and 80. That means 0.3% of the data would lie on the outside. And since we have symmetry, we would have half on each side. So we're going to take 0.3% and divide it by 2, which is 0.15%. So there aren't very many that are greater than 80. All right, last problem. On number 11, it says a student scored in the 75th percentile on a standardized test. What does this mean? Well, that doesn't mean they got a 75% on the test. That means they did better than 75% of the other people that took the test. So he did better than 75% of the students who took the test. Or in other words, 25% did better than him. All right, and that's it for this second review here.